Hello and welcome, and I'll be walking you through our entire project. This is Team Imperium, and this is our submission for Datathon, the Datathon 2024. So this is our project report, and it is just a brief summary of everything. So the main issue or the problem statement given to us by given to us by DataCamp, was to find a way to use data to effectively create a solution that can help improve students' performance in critical examinations. So the scenario they given to us was that we should imagine that we're a contract worker assigned the responsibility of creating a database, creating a pipeline, building it, and trying to look at the way the data can help the students improve more on their grades. So that's the base of the entire project. So our own solution was that since data is not really present like that in African countries, we decided to simulate. And we didn't just simulate the data, we made our research, we visited schools, and we got information on the way the metrics are, the kind of information that they keep. Although most Nigerian university and most Nigerian secondary schools do not keep a lot of information. Most of what we were able to see were the grades. But when we checked and we looked online and we looked at how a school system should be, we concluded that we're going to make our own data. And this is our report. Let me see. This is the way our data is. We had the extra column, we had the jam column, we had the WAEC column that talks about student performance in WAEC, we had the mock column, we had the classroom, the student table, rather I'm saying column, stuff table. So that's basically all we decided to use. There was thoughts on using things like the teachers table, student access to online materials, and we decided to start with this simple one to see whether there is even any chance that factors can even affect a student's academic performance. So in the issue of using historical grades, there was this consideration that we should use the grades of their a summary of all the grades that they've had throughout the school. But we decided that let us just look at the mock, since that's the one that mimics the YX system. So that's what we used, and that's how we arrived at our data schema. The data schema will be uploaded on our project in Tech website. So same thing, this is the data pipeline we created, and I would like to show how the pipeline worked, and I would like to show you a bit of the data. So this is now BigQuery. So this is the BigQuery. This is after we created the data, we put it in a pipeline, and we're using BigQuery because BigQuery, at least we can use this as a free, but we can use the free version, unlike other ones like Amazon Redshift, Snowflakes, which we have to pay. So this is a startup, and we decided to use free resources. So this is the classroom table. It contains classroom ID, classroom type, classroom year. We have extras table that talks about the extracurricular activities performed by the students. You have the jam table that talks about student performance in jam, mock, and all. So let's just look at the student table and try to get an overview of how it looks like. So this is just like normal simple basic query with SQL. So select all from our database is school DB, so school then DB. So once I run this, we should get select all from school DB dot the table we want to select student. So this is it. So we should get our result now. So this is all. You can see we have the name, the gender, the phone number, classroom, age. All these are generated. So we generated it ourselves because there is no way to fully extract this kind of data from in an economy like the African economy. So back to our presentation. This is the kind of analysis we did. We didn't just want to do exploratory data analysis and use visuals. We wanted to improve and use statistical tools so that we can say we are confident that at a particular rate that what we are saying is true. So as usual, all the analysis were, we use the critical value of 0.5, and which means that our confidence interval is 95%. So now this is the first thing we noticed. The gender has an impact on the relative scores, and you'll be looking at what are we trying to do here, because we have average score for mock, average score by WAEC. So we simply assigned values to grades. So anybody that has A1 will get a value of 8, anyone that has B2 will get the value of 7, and so on till you get to F9. Anybody that has F9 has a value of 0. So we took that and we summed that to get each student's mock score, WAEC score, and JAMB is obviously just one number. So that's how we add the JAMB, average mock, and average WAEC score. So we can see that from this, the guys are performing more than the girls in all the exams taken. So gender is like a factor, and we considered using statistical analysis. We used the t-test analysis of dependence to check whether gender is dependent of JAMB score, and we found out that we had to reject the null hypothesis and conclude that gender actually has an impact. So we had other factors like highest parent education. So this one is basically telling you the highest level that the parent is educated. So these ones are the ones that their parents at least finish from university, secondary school, primary school, and education. We can see that people that parents finish from university are performing well than the rest of them in everything, except from in this one that in the WAEC that shows that people that their parents finish from primary school too are actually performing well. You can see that the results are consistent across tertiary and primary. Same thing here, tertiary and primary, and why the other two are just minimal. So the ANOVA test also confirms that there is an effect of parent test on grades, because we use the ANOVA test to confirm that there is actually a significance in this, where there is a significance of parents' highest education level. So we can conclude that parents might have interest in their students' work based on how educated they are. For example, somebody that his parents is illiterate might not even ask him, have you done your assignment, have you done this, have you done that. They don't know how the STEM works, so they will not be able to give the student enough discipline. So that's just one of the things we noted in our analysis. We also have supporting parents, people that are supported by their father alone due to reasons, maybe divorce, or maybe the mother is dead. People that they are supported by their mother alone due to the same reasons, and people that have both support. And we can see that you would think that the both support would have more, and that's what we have in this scenario. So we use the ANOVA test, and we can see that there's an effect of parental support on grades. So this is just to let parents know that they actually influence the grades of their students. So if you're in a scenario where you are doing one supporting your child and you are doing a lot of other things, it's not going to be easy. The child cannot get the enough attention he needs if he asks questions, and also he has to just figure things out himself, except if he has uncles and aunts that can help him. So this is actually a factor, and this is something we notice also. So the third thing we note, the other thing we notice are the extracurricular activity, and this is the one that by far stands out the most, because looking at the extracurricular activity, we can say that people that pick a literal type based type of extracurricular activity tend to perform well in all the categories. And what do you mean by literal based? We know that there are a lot of extracurricular activities, and without grouping them into literal and sports and new, we will not have enough pattern to recognize. We have extracurricular activities like playing football, playing basketball. We just grouped everything as sport, and we have the ones of literal, because some people perform their extracurricular activity. They tend to read novels. Some people tend to join clubs like the debating club. They try to write. Some people try to even study extracurricularly. So with their extracurricular with their free time. So these are the people, and we can see that people that actually pick the literal based activity are performing well. So this is a significant factor that affects students' grade. So we also did other plots, and from here we can see the age, jam score, YS score, mock score. We can see that the age is normally distributable. It is not really, but it is a bit normally distributed. Jam score is normally distributable. It's not centered. There's a bit of the center is basically lower than what you expect, like it's lower than the median. So if you say the center here being at this point means that most people do not perform up to the average, and that's what the metric will go that 78% of people did not enter 200. So the average of this data is not up to 200. So and we can say that it follows the normal distribution, which means that few people passing, few people failing extremely, and they're just the people in this 180 190 region. So and the majority of people are in 180 190 region rather. So we can see WAEC score normally distributed to, and mock score also. WAEC and the mock score even fact almost follow the same pattern. And we also calculated the correlation, and we can see that for these exams, mock and WAEC are highly correlated with 0.87. So it means that schools can control how good a student performs well in the WAEC by preparing them highly for their mock, because passing the mock exam means that they can pass the WAEC exam. And we can see family size is negatively correlated, which means that the more you are in your family, the lesser your grades tend to be, and that makes a lot of sense. We can see age does not really have an effect, and so on. So going on, we can see the distribution here. We also built a model. A model was built to effectively predict student grade. So we use all the information and we built a model. So I'm going to be showing the model in a bit. So this is the model that we built. It is on Streamlit, and all you have to do is pick your gender, pick extracurricular activity. Just pick sports. I'm a sports person. Commercial or science. I'm a science student. So let's say in mathematics, I'm good at math. So I'm going to give, let's say I had 75 in the mock exam. English, I'll probably give myself 60. And you can see that as we are putting it, the table is getting updated. For civic education, it's a very, very simple course and people tend to pass it. So let's say I have 80 in that course. Electronics, I'm not really good at that, so I can put myself 57. Economics, let's say I have 67, and biology 63, physics 55, chemistry, I'm not good at chemistry, I'll give myself 50. Geography, I'll give myself geography at 60. Then supporting parents, both highest parental level, upper tertiary, family size, you are 5. So with this now we can see that it's trying to predict what I would do, and you can see that I will have A in mathematics. Even when I add A, I will have A in mathematics. I'll probably have C4 in English, A in civic expected, C5 in electronics, A in economics, failing biology 20. Even if I picked the WAF 63, but he said I'm going to fail biology. Same thing with physics, same thing with chemistry and geography. So that's basically, and it will tell you the areas you need to improve. So that's just basically the model we developed. Except from that, some of the model development part, we also got the metrics on the model. We had a mean absolute error of 3.9. So we converted the model, all the grades into numbers like randomly. So anybody that has grade A1, randomly gave the person any score between 75 to 100. Anybody that has B2, randomly gave the person any score between 70 to 74. So these are the metrics we got. This is the mean absolute error. It means that the model had the model was predicting, I was getting an error at least 3.9 in each prediction. So we had the mean square error of 98.6, which emphasizes the error, because the error is now squared. We have the root mean square error of 9.9. We have the half square of 89, which shows that the our model is explaining 89% of the data variability. So we also have our findings. From what analysis and everything we did, we see that male students tend to perform better than female students. Students who pick literature based extracurricular activity outperform students who picked sport extracurricular activity, along with those who didn't pick anyone at all. So we've shown that already. Students who belong to homes with a large family size at times tend to perform poorly. During the analysis, people that are in family that have in family about 6 7 or so tend to perform poorly, and you can deduce that it is because of the fact that those students might not have their personal space for reading, they might not have their personal tools to read. So we noticed that there was a weak correlation between those variables. Students with educated parents perform better than students with illiterate parents, and I've explained this earlier that parents who are educated tend to be more interested in the student education, while parents are not educated do not really have a glimpse of what is going on, so they can't really support the student. So students who have support from both parents outperform those who get support from just one parent. So students who pick that their support is coming from both parents outperform those that their parent is that divorced, or maybe they've lost one parent through due to one traumatic event or another. So that is another finding we're able to get from the analysis. So there is also the recommendations we made from our analysis. The recommendations we made, these are some of the recommendations. There needs to be a proper investigation in the school based concerning the gender category, because we feel like there should not be any significant effect of gender on the student grade. A boy and a girl could relatively perform up to standard. It's not as if boys should perform up to standard more than girls. So we actually we are going to encourage more students to perform literature based activities, because we found out from analysis that people who perform literature based activities like reading, debating, have probably fostered a love for reading and critical thinking, which helps them perform better than those who do not. The result from the mock exam was better than WAEC exam when we checked on the average. So which means that the school mock exam is not up to standard, because you performing good in your mock exam, coming to WAEC and now performing not as good, means that the school needs to improve the level of the mock exam, so that even it will be better if students fail the mock and when they get to WAEC they now perform well. It means that the mock was very very strict and the WAEC was now relatively easy for them, which would have them have a greater impact. So we also saw features like in the JAMB now, the UTME exam, people relatively failed the UTME exam more than any of the exams combined. So the solution would be that maybe students are not ready for computer based exams. So that's the only reason why we can say they are passing mock exam, they are passing their WAEC exams, and they are failing their UTME, because of they are not ready for computer based testing. So, and if the school can do anything to increase the readiness of the students computer based testing, there might be a likely better result. So that is some of those are some of the recommendations we made from the analysis. We also would recommend that the model which we built should be used to predict the students' grade before final exam. Even if the model is has a chance of predicting it wrong, it can highlight students that are not ready to write the exam, that would have like bad grades from the exam, and the school and and the educators can come together to monitor those students to reduce the failing rate. So other recommendations are we can use additional features to enhance our understanding of the factors affecting academic performance. So such features are attendance rates, access to the internet, and so on and so forth. So those are just basically our recommendations. So the last thing is we created a dashboard that would report. That is connected to it's connected to the data we got from BigQuery. So it is a data pipeline. Once the school gets data, it is uploaded to BigQuery. BigQuery automatically sends it to Local Studio, and this is why we use Local Studio is because of it is connected to BigQuery, and that connection is seamless, which is better, and it is accessible online, unlike Power BI where we need a payment account to make it accessible online. So we can see that we had 185 students. Out of the 185 students, we can see that we have science and commercial students and students one in this set. So that's 2025 set. And students who graduated this year, 2024. That's the last set. And we can see that there are 99 that graduated last set, and we have 86. So this is just basically a representation of data. This is the pie chart of supporting parents. You can see that according to the distribution, we have more males than females in the school. You can see that the literal based choice of recreation is relatively smaller than the two other fields, and that is like worthy of our notation, because we know that people that chose the literal based form of recreation tend to perform well than others. We also have the bar chart of parent educational level, and we can see that people whose parents stopped at the secondary level are the most are populous in our data set. So we can check the WAEC analysis, and what we just did for the WAEC analysis, we wanted to compare the WAEC analysis of the WAEC exam and the mock exam to know whether the WAEC is better and or not. So the only thing that we noticed that is a major impact was the chemistry exam. You can see that in the mock chemistry exam, people had A1, B2, B3, C4, C5, and C6 was the last one. When you go to writing the WAEC exam, you can see grades of A1 relatively small, B2 relatively small, B3 was a bit okay, then C4, C5, C6, D7 increased drastically, E8 was also there, we had F9, and in the mock there was somebody that even had anything lower than D7. So this suggests that probably the chemistry standard of that school is not good enough, because the mock exam people performed well and they got to WAEC and the failing rate just increased. So we also have the comparison for other courses, and we can filter by gender, you can filter by supporting parents. Lastly, we have the UTME analysis, and this shows that this year this black dot is our target value of 200. That means the students should be targeting 200, and we can see that when we took the average score was 198. It was not up to 200. At least the median value was not up to, so which means that a lot of people failed. And when we checked it by our analysis, we see that the people that passed the most, the people that had the highest score, are males who picked literal based activity. So we can see that they have a mean highest score of 242, which is well above the 200 mark. They have the highest score of 304, and their own lowest score, males who pick the literal based activity, their lowest score is 200. This is actually significant. Females, on the other hand, females who pick literal based also performed well, but we can see that there is another gender disparity between the male and female, where the male is performing more than the female. Female, on the other hand, their highest their mean was 223, their highest was 296, and their lowest was 185. So when we're going to pick the males who picked other categories, so we can see that the male who picked either the nil or the sports based is higher than the female who picked the either no activity or the sports based either, which shows that there's a disparity between the male and the female. So we can see that the male who picked sports have a mean score of 193, which is not far away, and the ones who pick no activity at all have 197. So they didn't really perform bad, but we can see that female who tend to go into sports performed the lowest with 184, an average of 184 in their exam. So we have concluded on the findings already, we have concluded on the recommendation already. This dashboard was just meant to enlighten us visually more on the data. So that's everything concerning the insights we've gotten from the data, and that is the demo of our Streamlit application and our interactive dashboard. Thank you very much.